Once we have introduced all the data, we click on proceed, and then the program will show us here below the values for wheat and sunflower of the requirements of nitrogen, phosphorus and potassium, and phosphorus and potassium are also expressed as P2O5 or K2O that are frequently used. Then we have to input data for the products that we want to use as fertilizers. We see that we have two windows here, one named NPK that shows a list of fertilizers that are sorted according to the adequacy of the concentrations for meeting the requirements, in this case, of the wheat, the first crop in the rotation. We select the first, which is the best suited for this crop. We click on plus, and this would be a complex fertilizer applied before planting and incorporated into the soil. The idea is that this fertilizer should supply all the phosphorus, all the potassium, and a maximum of 40%, because we had selected a value of 40 in the previous window, maximum of 40% before planting. Then we will need to complement with some straight nitrogen fertilizer. For instance, let's select calcium nitrate. We click on plus, and this is not incorporated and not applied before planting. This will be applied after planting. We click on proceed, and now for sunflower we open the NPK, and the best suited would be 71006. Note that we provide a full list because maybe the best suited is not available at our dealer. But let's assume for this example that it is available. Click on plus, it is incorporated and applied before planting. Now we will need straight nitrogen fertilizer. Let's see what happens if we apply calcium nitrate incorporated before planting. We click on proceed, and we will get the results back, where first we have the complex fertilizer, the total amount, and the straight nitrogen fertilizer to be applied after planting. The same for sunflower, along with the cost in monetary units per hectare. Now, in this table, we see the values of nitrogen losses by volatilization, denitrification, leaching, the total loss of nitrogen, and the percentage of the applied nitrogen. The acidification is expressed as kilograms per hectare of calcium carbonate that we would need to compensate for this acidification. Therefore, if we have a negative value, means that the soil is not acidifying but basifying. In other words, the pH is increasing. On the other hand, to the right we see the rotation balance for nitrogen, phosphorus and potassium. They are perfectly balanced, but for calcium we are applying an excess due to applying calcium nitrate, magnesium a slight deficit, and sulfur a surplus of 22 kilograms per hectare per year.